My name is Nur Farhana binti Muhammad Faizal.
Hi, my name is Nur Shazwani.
Hi, my name is Nur Akila. Differentiation is a fundamental concept in calculus that measures how a function changes as its inputs changes. In simpler terms, it tells us the rate at which one quantity changes with respect to another. Now, question 1. Explain the meaning of differentiation and what are the techniques of differentiation. As we know, differentiation is a process in calculus that determines the rate at which a quantity changes. More precisely, it finds the derivative of a function, which tells us how the function's output changes as its input changes. In the simpler terms, differentiation is about finding the slope or the steepness of a curve at any certain point. Now we are going to move on to what are the techniques of differentiation. Here are some of the examples that we use in technique of differentiation in calculus. We've got 5 here, which is constant rule, power rule, product rule, quotient rule, and chain rule. But in calculus 1, we mainly use 3 of the rules only, which is product rule, quotient rule, and chain rule. Now let us move on to question number 2.
Question 2 asks us to find dy dx for the following function. For question A, we have 3x squared secant x plus 2. When we let u, we will get 3x squared, and then we need to differentiate the u, and then we will get 6x. We will let v as the secant x plus 2, and then we need to differentiate v, we will get secant x plus 2 tan x plus 2. Since this equation is the multiply of the two different functions, we will use the product rule, which is the product rule is, formula of product rules is dy dx equal to uv prime plus the width vu prime. For this equation, we will get the answer as the dy dx equal to 3x squared multiplied with secant x plus 2 tan x plus 2 plus with the secant x plus 2 multiplied with 6x. The answer will be 3x squared multiplied with secant x plus 2 tan x plus 2 plus with the 6x secant x plus 2. For question B, we have the equation of y equal to 4x plus 2 divided with cos x. We will let u and get the 4x plus 2, and then differentiate of u, we will get 4. We will let v and we will get the cos x, and then we will differentiate v, and then we will get negative sin x. Since this equation is the divided of two different functions, we will use the quotient rules. The formula of quotient rule is dy dx equal to vu prime minus with uv prime divided with v squared. For this equation, we will differentiate y, and then we will get as the dy dx equal to cos x multiplied with 4 minus with 4x plus 2 multiplied with negative sin x divided with cos x squared. For the answer, we will get the 4 cos x plus with the 4x plus 2 sin x divided with cos square x.
For question 3, given y ln 3x minus exponent power of 2x plus 1 minus tan 4y is equal to 0, find dy dx using implicit differentiation. So for this question, I like to break it into parts. So it will be equation 1, equation 2, and equation 3. So for equation 1, y ln 3x, we will use product rule since we have two variables y and x. So dy dx equals to uv prime plus vu prime, uv prime plus vu prime. So dy dx equals to y power y over x plus ln 3x dy dx. For equation 2, it will be exponent power of 2x plus 1. So if we differentiate it, it will get dy dx equals to 2 exponent power of 2x plus 1. For equation 3, tan 4y, based on the table given on our book, Tan, if we differentiate tan, we will get sec power of 2. So dy dx equals to sec power of 2 for y. And if we differentiate it, we will get 4 sec power of 2 for y dy dx. So after we have differentiate the parts, we combine it into one equation according to the equation given by the question. So and then bring dy dx to the left, and then factorize dy dx. After we have factorized dy dx, so lastly dy dx equals to 2 exponent power of 2x plus 1 minus y over x over ln 3x minus 4 sec power of 2 for y.
Now in this case, we are going to use the formula for linear approximation, and we have to correct the answer to 3 decimal places. Now the formula for linear approximation is f x initial plus delta x equals to fx initial plus f prime x initial multiply with delta x. In this case, delta x will be represented delta x is extracted from the formula of x minus x initial. We are going to let fx equals to x square root of 4 minus 2 over x square root x. And then we are going to lose the square root sign. So it will going to be x to the power of 1 over 4 minus 2 over x to the power of 1 over 2. Now we are going to lose the denominator, which will be again x over 1 over 4 minus 2x to the power of negative 1 over 2. And now we are going to use the second derivative. It will be f prime x equals to 1 over 4 x to the power of negative 3 over 4 minus x to the power of negative 3 over 2. So we are going to rearrange it again as it is a worse. So it's going to become 1 over 4x to the power of 3 over 4 minus 1 over x to the power of 3 over 2. Now the given value that we got is 80.99, and in this case we are going to make it a whole number, so we are going to choose the value of 81. So we already have the value for chosen value and the given value. So we are clear to use the formula of delta x, which is x over x minus x initial. So 80.99 minus 81, we will get the answer of negative 0.01. Now we already have the delta x here. Now we can substitute the form. We can substitute the value into the formula that we have derived earlier. So 80 to the square root of 4 minus 2 over square root of 80.99, to equal it with with the initial value, with the chosen value of 81 plus f prime 81 multiply with negative 0.01. Now we are going to proceed with the formula, which is 81 to the square root of 4 minus with 2 to the 2 square root of x square root x, which is square root 81, plus with 1 over 4x, which is the second derivative that we have got, 1 over 4 multiplied with 81 to the power of 3 over 4 minus 1 over 81 to the power of
3 over 2.
And we are going to multiply it with negative 0.01. And for the first equation, we will get 25 over 9, while the second equation, we will get 23 over 291600, and you will get the answer of 2.778. and and this is the question which have been corrected to 3 decimal places. Now let's move on to the conclusion.
So, from this topic, we can conclude that differentiation is the process of finding instantaneous rate of change of a function based on variables using many techniques. That's all from us. Thank you.